All right, boys and girls, welcome back to the drive-through as we make our way through this data chapter. It's actually getting significantly easier. I love it. This chapter makes total sense to me. This section does, and I feel really good about what we're learning together. Okay. All right. So here we've got. We're going to learn about residuals today, and what they're saying is that the correlation coefficient isn't the only tool we have to measure how accurate a line is as far as how it fits the data. Okay? So what they want you to do is make a regression line from that. So we're going to pull up our calculator and turn it on. All right, let me pause the video real quick. All right, we got our calculator on. Let's go to Stat. Let's edit our lists. Oh, nice. I already have it typed in from earlier because I was getting ready for this video. So notice I've typed in 1 through 6 for list 1. I've typed in 10, 13, 7, 22, 28, and 19 for list 2. I've gone to the catalog, and I've turned my, what is that called? Diagnostics on. So now let's go to Stat. And let's calculate the linear regression of our data. We got list 1, list 2. All I need to go down is to tell it to calculate. And boom, it's y equals 3x plus 6 with a correlation coefficient of 0.7087. So pretty strong. No, you would not call it 70% accurate. You would just say fairly strong. Good enough? Notice, to create a scatter plot and graph the regression line, look, we got it right. 3x plus 6. So far, so good? Do you see that the regression line is written here in red? Does that slope look like it's positive or negative? Does the y-intercept look like it's around 6? Sure, we're moving on. All right, now it says to draw a line from each point to the regression line. The segment's drawn below. So it looks like you're drawing vertical lines. The residuals are the lengths of these segments. How can you calculate the length of each segment, Carson? Yeah, just, so, yeah. This looks like it's about 2 away. This one looks like it's about 2 away. This one looks like it's supposed to be at 15 or so. And so it looks like it's at about 8 away, negative 8. So that's how I would calculate them. General, if the data point is above the regression line, the residual is positive. If the data is below the line, it's negative. Knowing this, use your plan from number 1 to create a table of residual values. I think we have that table. Nope. So, we have 1, 2, 3, 4, 5, and 6. Here are our residual values. All right, 1, we look like it is, we're going to call that positive 2 away. 2, positive 2 away. 3, negative 8. 4, it looks like 4 to me. Are you okay with that? 5, it looks like 6 to me. 6 or 7. And 6, to me, that looks like a negative 5. A little bit bigger than this 4. You okay with that? So, hey, remember these numbers. 2, 2, negative 8. 4, 6, negative 5. Nope, nope. I said remember. 2, 2, negative 8. 4, 6, negative 5. 4, 6. So what I've done is I've plotted the residuals now. Well, here's what I like about them. Some of them are above the line, some of them are below the line. That's good. That means our line of best fit relatively accurately split our points. Think about what residuals mean and answer the following questions. If a residual is large and negative, like this one, what does that mean? So that means that it was significantly underneath our line of best fit. Let's go back and take a look at 3. Look, 3 is significantly below our line of best fit. It could be an outlier. What does it mean if the residual is equal to 0? That means it's lying on our regression line. It's exactly the point that the regression line predicted. Does that make sense?
So basically the residual is a margin of error.
Yes, the residual is exactly a margin of error. Okay? If someone told you that they estimated a line of best fit for a set of data points and all of the residuals were positive, what would you say? So if we went back to this graph and all of these points were up here,
I would say that generally all the points are above average.
nope. If all of your points were up here, then I don't think your line of best fit was very good. Your line of best fit should have been higher. That's what I think. Does that make sense to you? So let me ask you again. If someone told you that they estimated a line of best fit for a set of data points and all of the residuals were positive, what would you say?
It would have a negative. It would be a very bad.
Your line of best fit was too low. Okay? If the correlation coefficient for a data is equal to 1, what will our residual plot look like? I want you to get this right.
It would be perfect.
So what would our residual plot look like?
It'd just be on this line.
All of them would be where?
On the line.
No. Where would our residual plot look like?
That would be.
They would all be 0. Well, that's not what you said.
They'd all be on the line.
They would all be on the axis, not the residual line, not the line of best fit. Well, they would be, but the residuals would all be 0. All right. So statisticians use residual plots to see if there are patterns in their data that are not predicted by their model. What patterns can you identify for the following plot? Indicate whether the regression line is not a good model for the data. Based on the residual plot, are there any points that might be outliers? So, here's what I like about this data. To me, it looks like there's about as many points above the residual line, positive residuals, as there are negative residuals. Okay? So I think this is probably a good line of best fit, or a good, what do they call, regression line. Does it look like there are any outliers? Those, maybe this one, those, and maybe those. Those are all almost 10 units away from the residual line. That seems pretty significant. And maybe you'd throw this one in there too then. Okay? So all they're asking us to do is think right now. Well, this one jumps out as an outlier.
Yeah.
Other than that,
I don't think it's a good model.
why don't you think it's a good model?
There's not close enough points, or not close enough. There's only 6 points on the bottom.
6 below, 1, 2, 3, 4, 5. 6 below, 1, 2, 3, 4, 5, 6, 7, 8 above. But what might be causing that, Carson, is this outlier. Because that outlier is so much further below than any of the points that are above. It does. So we might be better off making our regression line by throwing that piece of data off. Does that make sense? Excellent. So yeah, maybe it's not a good line. Not the best. All right, what about, this is actually number 10. That didn't copy over. What about number 10?
Definitely not. So that was an outlier for sure.
We've got a couple outliers. This one certainly looks like an outlier. That one might be an outlier. Here's what I noticed. This might be, we might not want to pick a linear regression line for this, because look, this one is negative, that one's positive. This one's negative, that one's positive. This one's negative, that one's positive. This one's negative, that one's positive. This might be like a quadratic. Might be a better.
Because it's kind of got that little...
It's alternating. But I actually do think this is a good regression line, because you got 1, 2, 3, 4, 5 points above, 1, 2, 3, 4, 5 points below. Okay?
I guess we could consider those two to be outliers.
Those might be outliers. All right, what about 11?
Looks like there's a decent number of points there.
It's a lot of points, and it seems like they're well spaced. How many points had a residual value of 0?
Looks like
2 of them, with another one that was super close. I like this. I think it's good data. Outliers?
that guy up there for sure.
Looks like an outlier to me. Possibly this one as well. Okay? We're just about done. We're done. Boom!